So I saw JA Advanced level question which can be appeared in a future JA Advanced. So in this we will talk about intermolecular aldol condensation and a concept about intermolecular condensation or any other aldol condensation. So this is a question from our class 12th chemistry, which is aldehydes and ketones and carboxylic acid, where we study about aldol condensation, where aldehydes and ketones undergoes aldol condensation. So from this we will learn how this reaction takes place. We have both two parts. One is part 1 and part 2. In one part we have the reactant is reacted to some one product, and in another we have another product. So here one reactant is used to produce two different products. Now from this we can find which one is a better path, and the options are given as option 1, path A is better than path 2. Why path 1 and path 2 are different from each other? Let's discuss about that. So in the path 1 we can see that there are two acidic hydrogen. One is this one, which is this acidic hydrogen, and this acidic hydrogen. Now what do you mean by acidic hydrogen? The hydrogen that is acidic and which produces a carbon anion here and here. Now why this acidic hydrogen is used? This sodium hydroxide is a base which seeks acidic hydrogen from one of the carbon. Now which carbon produces acidic hydrogen? According to the concept of general organic chemistry, the acidic hydrogen is produced by one of the carbon from which the carbon anion is stable. Now from which of the both carbon anion is stable? From here you can see the carbon anion which is produced. He is a 1 degree carbon anion. So carbon anion, the stability goes like methyl carbanion is more stable than 1 degree, then 2 degree, then 3 degree. So 1 degree carbon anion is stable. So here if you see, the carbon anion produced is a 2 degree carbon anion, which is not stable. From here we can see that this will be a acidic hydrogen. So this will further react with sodium hydroxide to produce water, and it will produce a carbon anion. This carbon anion, which you can see here, will attack this carbon because this carbon is positively charged and polarized due to the presence of oxygen. This sp2 carbon atom will be polarized to positive charge, and this negative charge will attack here, producing an alcohol. After heating the alcohol or the product or the intermediate formed in this process, we will get a product, this product, after heating. So what you think, we will think here that this carbon anion is stable, so this carbon anion will be stable, so the product will be in this path. So we will think that this path is more stable. But one thing here is the last end product is not very much stable. If we see the point of view of hyperconjugation, we have 1 and 2, only 2 hyperconjugation structure. So we can say that even though there is a resonance, ignoring the resonance, we can see other stability factor. Here we have hyperconjugation. Here hyperconjugation, we have only 2 alpha hydrogens with respect to this carbon. So we have only 2 alpha hydrogen, making the 2 equivalent hyperconjugation structure. So since there is no heating, there is heating present here, this should be according to thermodynamically controlled product. So thermodynamically it should be stable, but thermodynamically this is not stable. So if you see the path 2, here we have this acidic hydrogen to be taken. So from here, if we go further, we will see that the carbon anion will be produced here. So this carbon anion will attack this carbocation, sorry, not this carbon anion, this carboanion will attack this carbocation, so which is produced by the oxygen. This is polar, this there will be a partial positive charge. This carbon anion will attack this, so that the product will be this. So during this product we have two hyperconjugation. We have 1 2 3 and 1 2. So we have totally 5 hyperconjugating structures. So we will get the product to be this.